Why is there light on the Earth but not in space? Why is the sky dark at night? And if there is a reason for that, definitely that must also be the reason why the space is dark, or isn't it? Let's check that out. Welcome to our channel once again, where you get real updates about space and technologies. In today's video, we will be discussing why there is light on the Earth but not in space. Don't forget to hit the like and subscribe button, and also smash the bell icon so that you can be notified when we release a new video. Stay tuned to the end of this video as we unveil the mystery behind this. Thanks. You might think the answer is obvious, but the sun isn't up. But the only reason the sky looks blue during the day is that the sunlight scatters off of the atmosphere. If we didn't have an atmosphere, like on the moon, the sky would always be dark even when the sun is shining. Why is space dark? Space is full of stars, countless stars, which are all about as bright as the sun. And in an infinite eternal universe, no matter what direction you picked, if you looked far enough in that direction, you would see a star or galaxy. So the whole sky should be as bright as the sun, night and day. And since it's not, does the darkness of the night sky mean that there is some distance away from us when stars and galaxies just stop? A boundary between something and nothing? An edge to the universe? Not exactly. All of our evidence seems to indicate that space has no edge, but the universe itself does. Not a spatial edge, but a temporal one. As far as we know, the universe had a beginning, or at least a time about 13.7 billion years ago, when the universe was so small and crumpled up with itself that our standard notion of space and time breaks down. And since only a finite amount of time has passed since this so-called beginning, that means that some of the stars necessary to fill up the brightness in every direction are so far away that light from them plain hasn't had time to reach us yet. It's as if the universe were a big thunderstorm and we're still waiting to hear the thunder from the distant stars. But wait, it's better than that. Since light takes time to travel across the universe, when we point our telescopes at something really far away, we're actually seeing that part of the universe as it was when the light was emitted. So, when we look at 13.5 billion year old light, it's not that we don't see stars just because the light from them hasn't gotten to us yet. We don't see any stars because we're getting a peek at the universe before any stars had formed, a starless universe. Now, that sounds to me like a pretty good reason why we look up and see a dark night sky, but it's not. I mean, we can indeed find points in the sky where there aren't any stars by looking past the earliest stars and thus further back in time. But even when we point our telescopes past the earliest stars, we still see light, not starlight, but the light left over from the Big Bang. We detect this cosmic background radiation coming more or less evenly from all directions, forming a background beyond the stars. So I guess the night sky isn't actually dark to begin with, right? So if our telescopes tell us that the night sky isn't dark, then why does it look dark? Here's a clue to the real answer. When the Hubble telescope photographed the distant stars of the astoundingly beautiful Hubble Extreme Deep Field, it took the picture using an infrared camera. Why? Well, distant stars and galaxies are moving away from us because the universe is expanding. So the same way a record slowing down lowers the pitch of my voice, the Doppler effect causes stars moving away from us to become redder. And the further away they are, the faster they move away from us, and the redder they become until they become infrared. And then we can't see them anymore, at least not with our human eyes, and that's why the night sky appears dark. In summary, if we lived in an infinite, unchanging universe, the entire sky would be as bright as the sun. But the sky is dark at night, both because the universe had a beginning, so there aren't stars in every direction, and more importantly, because the light from super distant stars and the even more distant cosmic background radiation gets redshifted away from the visible spectrum by the expansion of the universe. So we just plain can't see it. Finally, we've shed some light on why the night sky is dark and why it isn't. Almost everyone admires the lovely blue sky on a crisp, cool autumn day. As early as 1500, Leonardo da Vinci tried to explain the sky's color. His notebooks show he monitored sunlight passing through wood smoke, suggesting he understood the basic phenomenon of light scattering. Although the complete physical explanation for the blue sky is complex because of length limitations, we will focus on the primary mechanism. In the 1870s, the English scientist Lord Rayleigh weighed in with part of the explanation, but to understand his rationale, we need to know two things about how we perceive light. First, all colors of visible sunlight from the shortwave violet to blue, green, yellow, orange, and the long-wave red are emitted by the sun, yet not in equal amounts. The predominant color in the visible spectrum is blue. Second, our eyes detect green light better than the other colors, and they perceive blue light pretty well. Mixed, all the colors of visible light appear white to us. Imagine a cork at rest on the surface of a tranquil pond. A stone is then dropped into the pond, sending out waves that cause the cork to move up and down. The cork receives wave energy and then oscillates up and down, and similarly, light waves can interact with air molecules. However, the air particles do not keep the energy from light waves that fall upon them, but quickly re-radiate that light energy in random directions. Hence, the initial light that was coming from a specific direction is now scattered, re-radiated, in all directions. This scattering depends upon particle or molecule size and the wavelength of the incident light. Scattering is proportional to 1 dividend by wavelength to the 4th power. The long waves of sunlight, red, are less effectively scattered than the shorter ones, blue, by the small air particles in our atmosphere. Since red light has a wavelength 700 nm, about 1.7 times greater than blue light, 400 nm, Rayleigh's findings show that the blue light has about 9 times greater chance of scattering than red light. This scattered blue light goes out in all directions through the atmosphere and comes to us from throughout the sky during the day. However, when the sun is near the horizon, sunlight must pass through a thicker amount of the atmosphere than when it was overhead. As the light travels the long distance through the atmosphere, most of the blue light gets scattered about, and the light that remains has proportionately more orange, leading to the beautiful sunrises and sunsets we are often blessed to see. These scattering effects are not, however, constant. Lord Rayleigh's explanation ignores the effects of water vapor, dust particles, ozone, chemical pollutants, and eye response. All of these mechanisms can enhance or diminish the beauty or color of a sunrise or sunset. In space or on the moon, there is no atmosphere to scatter light. The light from the sun travels a straight line without scattering, and all the colors stay together. Looking toward the sun, we thus see a brilliant white light, while looking away, we would only see the darkness of space. Since there is virtually nothing in space to scatter or re-radiate the light to our eye, we see no part of the light, and the sky appears to be black. Some people believe we can see light. Yeah, I know, that's really funny. Some people understand that this room has dust particles floating in the air, and the particles reflecting more light appear brighter. To perceive brightness, 2 things are required: light and something to reflect the light to our eyes. Outer space has only one of these. Light isn't bright. Objects which emit or reflect light can appear bright. Light without objects is dark. Objects without light are dark. What will Earth look like if it's as dark as space? Kindly comment below. Don't forget to like and subscribe to this channel, and also hit the bell icon so that you can be notified when we release a new video. Thanks.